I think Sarah joined. Good morning, sir. Namaskar.
Good morning. Namaskar, sir. I'm audible, sir?
Yes, sir. Yes, sir. You are audible.
Okay.
Sir,
Thank you, sir.
if
Sorry
you
for the delay. Yeah.
no issue, sir. No issue, sir. Sometimes we are depending on the network,
Yeah. Right.
and some
Right. Right.
technical issues might happen. Sir, shall we start?
Yes. Yes, sir. Yes, sir. Yes, sir. We can start.
Uh, a very good morning to all of you, my dear participants. Today we are having the third day of this faculty development program on MATLAB and its application in artificial intelligence and machine learning. Again, today we have with us Professor Nikhil Rajput sir of Ramanujan College, University. There is a saying in education that learning without practice is of no use. If you practice more, you will again achieve perfect ultimately. MATLAB is such a program which needs rigorous practice, on the part of its users, and this can be learned from a teacher like Professor Rajput sir. So, sir, I welcome you all. I welcome you session. Now I am heading over the charge to you. You please, sir, continue the session. Thank you,
Yes.
sir.
Thank you, Atal sir. So without any delay, I guess we are already late. So I'm. Please, sir, allow me to share my screen. Uh,
Sir, let me
I
make
don't.
you the host so that you can handle this session.
Okay.
Now, sir.
Okay. Okay. Okay, so I'm just sharing my screen. Please let me know is if it is visible to all of you. Is it visible now? My
Yes, sir.
screen
Yes,
is
sir. It
visible.
is visible.
All right. So let's start with a session on regression analysis using MATLAB. And it is very important, as I mentioned yesterday, that there are three kind of analysis which we do on this this machine learning specifies, like one of them is regression, which is part of supervised learning. So supervised learning means we will be given the labeled data, and we have to find out, like we have to predict the future value. So in general we use regression to predict the future values of anything. So we have input variables, we have output variables, and based on input variables, we train the model. Based on input and output variables, we train the model, and after that we test the model. And now if the accuracy level is high, then that model can be used to predict the unknown value. We have some kind of input given to that model, then it can predict the outcome of that corresponding to that input variable. So I'm just sharing this data set using Zoom, which I am going to use, so that the participants, they can work along with me. So let me see. I guess I can use the chat, the data, if it is possible. Let me see. Otherwise, I will use a WhatsApp to share the data so that you can, yeah, use the data set along with me. Yeah, so this is a salary data set. Let me know if yeah, it is uploading. I guess you all are able to see this salary data set in the chat box which I had shared with you. Salary dataset.csv. Anyone, please confirm. Are you able to see this salary data set? Uh, no, yes, please let me know. Am I audible?
Yes, sir, it is visible.
And yes, and are you able to see the data set in the chat box of Zoom? I've shared that salary data set in the chat box. Please confirm if you're not able to see that. I will share it again. So with that salary set, let me use that data set for regression analysis. So what you will have to do, you will have to click on this import data. I'm just using CLC and clear all so that the screen is clear. Okay, and now just click on import data. Okay, and after this you can click on this import data, and it will appear in your workspace. So you can see salary data set 30 cross 3 table. If you double click that it has three columns. First column is just the serial number. Second column is the salary. So you can just confirm that this is there. So you can see serial number, years of experience, and salary. So here what type of regression analysis we are going to try, like based on number of years of experience, what should be the expected salary of that employee. Okay, so maybe we can delete this column, like we don't need the first column for analysis. So we can delete this column. So we just need two columns here, and this will be a very simple regression analysis where we have only two columns, years of experience and salary. So years of experience, based on years of experience, we want this can be called as a labeled data, because so we have if since we have output variable, that's why we will call it as a labeled data, and we are going to use supervised learning for it. And in the supervised learning, we are going to use regression for determining the future value. So suppose after this model train and we find the appropriate model, then we can say that some new values come here, like for example, we want to determine that what is going to be the salary of a person with a 12 years of experience, then the model should be able to determine the expected salary of that person. So let's use this data set for our regression analysis. So go to apps and go to this regression learner. And click on new session from workspace. Here you can see it automatically takes these two values, salary for for response, and predictor, years of experience. And this is correct. If it is not correct, then you can change this also. If you don't find it correct, then you can change, say you can exchange the rows, these columns also. But here it is correct that cell is the response, that means output, and years of experience is the input, that is predictor. Okay, so after, and you will be able to see this data. Okay, so you can see this original data set, salary data set, and this record number. So this is you just have to click on train, and the training will be done. And this model, you can see this is a fine tree model which is here, and this is the outcome. So salary is the outcome, and this is our predictor. You might be not able to find this cannot determine what is the response. Then you can use this plot, predicted versus actual plot. So this is, these are the observations, these dots are the observation, the real value, and it is trying to fit a straight line into it, perfect prediction line. So you can see it is somehow predicting it with some not exact accuracy, because you have this kind of error. So we can try to change the model. And these are the outcome results. So mean square error, which is the average error, and root of average error with the predicted values and the actual values. It calculates the distance between these two values, and computes a mean of it, and it is square roots it. So this is the mean square error is 9541. It is significant enough. R square value is 0.88. In general, it is, if it is closer to 1, that means the fitting is correct. Mean square error is this much, and other things are there. We just need to ensure that these things are low, like RMSE should be low, MSE should be low, and R square value should be closer to 1. If it is the model correct, predicting correct, then that means this regression is fine. You can also see the residual plot, which is again in the predicted response curve. So you can see the error is significant, less selected, and now we will have to click on train. Okay, so again you can see it's better. So you can see the errors, like R square is closer to 1, so 0.95. RMSE has been reduced, MSE has again, it is lesser than the previous thing, previous model. So you can say that linear SVM model is better than this tree model. Other plots of minimum, as it is not there, but predicted versus actual plot, residual plot, and response plot. The response plot is you can see and true values are these blue colors. So the model is provable. So this is linear accuracy results. You can judge that if the model is correct or not. You can try another model also. For example, if I try say fine uh, fine Gaussian model, or these are the simpler, well, so linear regression, but that is that linear equation y is equal to mx plus c type of model. Regression tree, it is computer science people, they use decision tree model to identify to use this regression analysis. And we have these SVMs based on hyperplanes. So quadratic SVM, linear SVM, cubic SVM, train. So again, the you can see it's not is lesser in this linear SVM. So out SVM is appropriate model too for this fine Gaussian SVM. The value of our SMEs is quite high if you compare it with the previous two models. So if we are using these three models, so then we can say that this SVM model, linear SVM model, is appropriate to predict the values. You can see the plots also, predicted and actual plot, residual plot. These two, you can see the distance is, if the distances are quite high, that means this model has this kind of error. If whatever the if it is close enough, then we can say that model is better. Okay, this distance, average distance is close enough, then we can say the model is better, not the that thing, like you know the distance between these points. Okay, so the average distance between these points. Okay, any question regarding this, or should I repeat it? No, no doubt. Okay, so I'm just doing it very quickly. I'm repeating this very quickly so that if you have missed this, then you can try. I'm again closing everything. What were the steps? Go to home, click on import data, click on desktop, and open your data set. Here you can see this import selection. Click on import data, and it will appear here in your this workspace. Just double click on it, and if you don't need any kind of no any column, then you can delete that column here. You can also delete while importing. So delete column variables, because we need only these two parameters. And go to app, and after that click on classification learner. Sorry, classes. I will have to use that regression learner. Go to apps, click on regression learner, new selection from workspace. Just make sure that it is correct, salary and years of experience, and just then click on start session. And it, by default, it has picked up this model. You can change the model, linear SVM, quadratic SVM. And after that, if this is selected, you can deselect this. We don't want that parallel computing. So just click on then train. It will train, and you can see the error and other things like this. This is like, it shows the direct values and true values. If they are close enough, then the model is correct. And you can also verify it with these values like RMSC, r square. If it is closer to 1, then the model is correct. RMSC, if it is less, then the model is good. MSC should also be have the lower values. So to compare, you can also change the model and try, like if I want to see this cubic SVM is, out of these two models, which model is good. So cubic SVM is little bit better than SVM. You can compare these values. RMSC 6167 and 55550. 5550 is lesser than 6167. That means we can say that cubic SVM is better than quadratic SVM model. And based on these plots, response, predicted, and residual, you can just make sure that these things are there. And this you can download these figures. For example, if you want to use it in your research paper, then you can just click on this export to figure, and then you can just download this figure to use it into your save, click on save. And say if you want to save as a JPG, PNG, any can save this figure to use it in your in MS Word or any platform. So save, and this figure is saved. So this is how regression analysis on any kind of data which is there. Any question related to this? Any doubt? So please be slow. Yes, please let me know if if you have any kind of if you have any doubt, or after that I will repeat anything. Please let me know if you want me to repeat any 2 times. If it is you have not not able to do this, then I will repeat it again. But you just need practice it along with me after this session. Let me ask any kind of doubt if it is there. Okay. So exactly, I'm just repeating this SVM. This regression analysis. What is the goal of this? Let me use this.
Excuse me, sir.
Yes, yes, ma'am.
Sir, for uploading data set, can we only upload CSV file or we can upload Excel file?
Yes, yes, you can upload Excel file also. It's no issue in it.
But
Okay, so
while
yeah, so
I have Excel
uh,
file and why when I go to export, then it is not showing for uploading.
it is not showing to Excel file.
Yes, sir. When I in MATLAB at first I go to export.
Mm-hmm. Import data, right?
Sorry, sir. Import data.
Mm-hmm. And desktop and
I'm sorry. And yes, yes.
so you're not able to import because it shows that you can see that all these
Okay,
files can be uploaded. Now you select this one. Okay, if it is not there, then select this the spreadsheet.
okay,
Okay,
okay.
and then try that thing. Okay, if it is
Okay, sir.
not,
Thank you, sir.
any other doubt? No. So let me just clarify what exactly is we are doing. So we have 2 things here: input and output, and we have this data. Okay, and output data. What regression will do that? If this is the label data because output is there, so we apply different model, say model 1, model 2. Okay, and we train this thing. Okay, so out of these data we have only say 30 data. So you may say that 25 will be used for train, or maybe 20 for training, and it may say 20. Let me pick some other random value like 22 for training and 8 for testing. So out of this of whole data, 22 will be used for training, and with 2 this model, say if I apply M1, then it will train the training means it will find the parameters related to this model. If it is a simple linear model, then it will try to find the value of M and C based since we are providing y as well as x to it, the output and input values to it. So the goal of training is by training we mean that this is going to find the value of M and C if it is a linear model, linear regression model. Then it will try to find the value of M and C based on this 22 data set points, and after that it will check that whether this model is correct or not. if this model is appropriate to find out the values unknown for unknown values, then it will what we will do, we have for this 8 values we have two y values, y as a predicted value and y the actual values. We have both things for this 8 data set, so we know all these output values, that will be the actual value. Okay, and the predicted value, it will compute based on, it will pass, since we have already computed mnc, it will pass the value of x to this model, and it will try to generate y. So that y will be called as predicted values, and the difference between these two, it computes with different measures like rmsc, msc, and r square. These three things are enough, and based on these values, if rmsc msc should be lower, should be less, and r square should be close to, on r square values generally take it value from 0 to 1 in general. There are some exceptions. So 0 to 1, it will take value from 0 to 1. That means if it is closer to 1, that means it is the model is correct. So we use model 1, model 2, in the, and we use these measures to judge the model, which model is correct to predict, which model is not correct to predict. Any doubt in this part? So these equations will be different. Like for simple linear model, this will be like y is equal to mx plus c. For SVM, it will be something different. For Gaussian regression, Gaussian SVM, it will be different. For cubic SVM, it will be different. And with all those models, it is like to find the parameters related to that model, so that it can find out the predicted values for unknown values, unknown input values. Okay, this, I hope this is clear. You, if it is not clear, then let me know and we'll repeat it again. And these are the graphs which you can use if you want to write something, research paper related to this. Okay. You can also try to find out, say, other data set. Let me show you from where you can find the data set. For example, if you are working on say agricultural data, so say this is a site where you can download the data, Faustat. So data set, for downloading the data set, I have mentioned few websites like Kaggle, and use data set research, data set search, Google data set search. And again here from this database, if you want to go for analysis of agricultural data set, then you can use this pow.org, crops and livestock products, download data. So it and select here you can select the element like yield, area harvested. For different crops you can search for it, and if you want to search for different years, then select all, and crops, say crops, and this is a like simple selection thing. So you can just select the crop. Say I just want to for the wheat, then I have selected this and click on download data. Okay, so it will take some time. So you can see identifying that this data can be used for regression analysis, because here you can see the year is there, and you let me save this, then I will open this data set. Now you can see there are different elements here. Here the year is there and yield is there. Okay, so other fields are, I guess, not important for us. So what we can do, and area harvested is there. Okay, so area harvested is there. No, area harvested. Okay, so there's some problem with this data set, but here, yes, you can have these two values only. So area, this yield and this thing. So you can just remove other columns to get. So let me try this. So again, I will clear here, clear all. Remove this and import data, desktop, pause it. Here I don't want every column, so what I will do, I will select this column only. This column and this column. Use the control button. So to select these two columns only, you can just click on this J and L, and press control button, so that these two columns are selected only, and then import selection, click on import data. Okay, so you can see now this is and this is a good amount of data to analyze. So we have 9548 cross 2. Now go to app and go to this regression analysis, regression learner. Start new session. Here, just make sure that these two columns are, so here I just want that response to be this and here to be this. So this is correct. Okay, so start session. And again click on train. So with the exception, as I said, this is very bad fitting because it is very, the values are very high RMSE and other things. So we'll have to change the model for it. So let me try linear SVM. Okay, so this, I guess there's some issue with the data set because all the values are here and it is not able to fit. Okay, let me see if some other models can be applied or not. Otherwise, there is some issue with the data set which I have downloaded. So we can avoid these kind of data set for our analysis, because you can see the result is quite bad. Actually, it's where the value of RMS is quite high, 10 to the power 6, which is actually very bad fitting. So we will have to avoid this. I guess there's some issue with the data set which I have downloaded, and you see that there's some, I think these are the constant values. Yeah, and very drastic change. Okay, so I guess I should have selected up to this point. Okay, so what I've done, like up to 62, it is up to 2021, and again you can see the 1961 is repeated. So I have made this mistake. So just make sure that these mistakes are not there. I will to select the values from the rows from 1 to this one only, 62. Then I guess it will be approved. So I will just, I'm trying it again. Any doubt till now? Because I am doing along with with the real data, so that you can see what mistake can be done. So you can see I have done this mistake by not observing the data. So apart from this, I will have to go to up to this column only, from up to 62. Let me select all these values, and after that I will delete it from MATLAB. So 64, and I don't need these columns. I need, yeah, I need this one, and I don't need these two also. Okay, I guess now it is little better data set. So even this I should rename it years, and okay, it is not changing, so I will delete this, and because yeah, year and values are already there, so I will have to do this column also. No, this row. Okay, so let me now use like now it will show it will displace a better result. New session, value year, start session. Yeah, now you can see the result is better. So I will train the model. Now you can see the results are a bit better. So the R square value is 0.92. That means it is a fine model. Let me try another model. Okay, so this is not a good model for it. So you can see this model was linear model was better than the linear SVM. So this fine tree model was better than. So in this case, you see this the R square value is 0.92. This is 10 to the power 5. We can select some other model to predict it, which can give a better result, but still it is acceptable. Okay, so the model which for the previous data set linear assume was was better model. For this data set, you can see that this fine tree regression model is better. So it we have to try different models to predict the values, so that it gives better result. Any question, any doubt regarding this? I've done everything from scratch, like what you can do with it. Any Yeah. Yes, someone's microphone is open. You want to ask?
Uh,
Yes,
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 sir. Am I audible?
yes, you're audible.
Yes, sir. Yes, sir. Initially, I was not able to understand. Now, I followed when you did it second time. So finally, what I wanted to ask that it is we who have to choose the model
Yes,
if
yes, yes,
we are not getting the proper prediction.
yes, exactly, yes.
Okay, so ultimately, I mean, AI cannot replace human being.
No, what AI definitely it is like impossible that AI can replace. There is no alternative for human being. But yeah, for automated, the what is happening with these models, like there are few tools like auto ml and everything, where it automatically tries to find out the best model for it. But here in MATLAB, and what whatever the problem we are dealing with, we have to select the model, and we have to train the model, and find out that for what kind of data set which model will predict better. Okay.
Okay. So one more thing. These the points of the result. Please discuss once again. Which value should be RMSE should be low. Root
Yes,
mean
yes,
square error that should be
yes,
low.
yes, yes, yes.
And I mean,
Ap-
is there
Apart from
any
R square,
range? Is there any
apart,
range,
no,
sir?
no, 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 no. There is no range of RMSC and MSC.
Okay.
But there's range of which is expected range. Actually, it is not always there that R square value cannot take a negative value or higher value. But it
Okay.
should be, if if your data set is correct, and you are doing it fine, then it should be between 0 to 1 only, R square value. And
Okay.
closer to 1 means it is a better result. So apart from R square value, all other values should be lower, on the lower
Okay.
side. Only
Okay.
R square value, it should be closer to 1.
One.
Okay.
Okay.
Yes.
Okay.
Okay.
Thank you.
Yeah. Okay, so this was about regression analysis, and this is not like simple regression what we are talking about, but there are other forms of regression. I'm not going to cover it in detail, but I will just show you, like you can have this uh, different tools. Analytics Vidya is a good platform to understand this. So linear regression, we have this equation where since most of you are from mathematics background, what you people can do, it's not like taking data set and finding predicting the values. This is done by statisticians, this can be done by mathematicians, this can be done by biologists. Anyone can jump into this field. But from mathematician point of view, you have this advantage that uh, you can try to find out a new model, kind of thing. So this linear regression is there, where this equation is there, and you can see SVM is based on hyperplane. Logistic regression is again, this is a S-shaped curve which is there. And yeah, there is one unique thing about logistic regression, that logistic regression is not used actually for regression analysis, it is used for classification. This is a unique thing. So apart from logistic regression, almost all other regression model are used for prediction. Okay, so logistic regression is generally used for classification tasks, which I will cover, probably cover tomorrow. Polynomial regression, where you have multiple independent values, where you have more input parameters, then polynomial regression can be useful for you. Ridge regression, this is totally mathematical thing which I even not cannot cover, because if you are a mathematician, then you will be able to understand these equations better than me. Lasso regression is there, quantile regression is there, Bayesian regression is there based on Bayesian statistics, principal component partially. So why I'm mentioning this, because mathematicians can play a role in finding new regression models. Okay, so based on data set, you can see if I go to this model, then you can see if this model
Sir, your voice is not audible right now.
Sir, is there any technical issue?
I think so
Okay, okay, okay. Fine,
because
sir.
no voice is coming from
Yeah,
other.
yeah. And even screen is not visible, sir.
Mhm.
Okay,
Let
fine.
us wait for some time. Okay.
Yeah, yes, yes, sir. Thank you.
अगर ऐसे गार्जियन आना शुरू हो जाए तो क्लास तो रनिंग होगी। यहाँ तो कोई आता ही नहीं है, पहली बार आए, मैं इतने साल से देख रहा हूँ, पहली बार एक गार्जियन आए हैं जो अपने
हेलो
बच्चे का ख्याल रख रहे हैं।
यस मैम, हेलो यस मैम, सॉरी, अच्छा मुझे डिस्कनेक्ट हो गया तो मुझे पता नहीं चला, सॉरी। अरे अरे मुझे लगा मुझे तो बता रही हो, कोई बात नहीं।
सर एक बार ले
All right, sorry, I guess I was disconnected और मुझे पता नहीं चला। So yes, yes, yes. So let me repeat this part again. Okay, someone's mic is open.
इवनिंग क्लास
SP यादव सर, आपका माइक
उसको
ओपन
नहीं
है।
है, धन सिंह रावत आएगा ब्रिंग हो गया वो अगर क्या नहीं
SP
पकड़
यादव सर,
अच्छा और नारा हो रहा था 14 तारीख क्यों
अटल सर, सर आप म्यूट कर सकते हैं SP सर को। तो, okay, let me continue. Yeah, yes, I guess so, ठीक है। So I'm repeating this part again. Microphone open छूट गया है। Yeah, mic. Okay, so I was discussing about neural network fitting. I'm using I will use the dataset which is already available there. So I guess my screen is visible to every participant. Is it visible?
Yes,
Yes, sir,
sir.
it is visible.
Yeah. So you see that there's a another tab which is is regression for regression analysis only. So neural network, click on neural network, click on next, and here I will use the sample data set first. Then I will show you how to upload your data set for it. So say if I use this body fat data set, click on import, it will import it, and it has say body fat inputs as input, and target is body fat targets. uh, and then click on next. Here you can change these values also. So as I said, I don't want validation data to be there. I have not covered this validation part. It is a MATLAB specific, few people use this validation thing. Otherwise, training and testing is there only. And testing, you can, if you want to increase, then you can increase. Now you can see the training data set is 75% of the training data set will be the data 75% of the data set will be used for training. Testing 20% data set will be used, and for validation 5% data set will be used. Okay, and click on next, click on next, and click on train. And if you see that a new will be there, new window will be there, and you can see all different diagrams. So if I click on regression, you will see these four graphs with their R values. R values closer to 1 is good fit. So you see that it will show all the training points also. So 189, it will show all the 189 points, and how this varied actually. And for validation, it is showing these points. For testing also, this is showing this in the third plot. And for all the values for training, validation, and testing, it shows in the fourth plot. The first plot for is for training, second is for validation, third is for testing, and fourth is for all of them. So you see these points closer to this blue line curve. Then this is, and the data points is with these small circles are the data points. Okay. Uh, so this is neural net fitting. It is different from what the regression we learned earlier, but with this you can also have different kind of outputs. Say you will be able to see the performance plot.
ये
So it will,
बिना उसके देना
yes,
सब कुछ अपने आप
any
कर रहा
question?
है नोट डाटा वाटा सब सर्च कर लिया नेट से डाटा सर्च किया और अपने आप
uh, कुछ
ऐसे क्वेश्चन
क्वेश्चन
का
पूछ
कितनी बड़ी क्वेश्चन था उसको सिमुलेट करना है और लिखने के बाद जैसे क्लिक कर रहे तुरंत उसके बाद
SP सर, डॉक्टर SP यादव सर, आप आपका माइक्रोफोन ओपन,
हाँ ये
माइक ओपन।
स्पीकर का है हमारा
SP यादव सर,
यस सर
आपका माइक ओपन छूट जा रहा है सर। आवाज आ रही है आपकी, ठीक है सर। Okay, so this is mean squared error plot, and you can see that these mean square error, the lower values indicate that the fit is good. Okay, so with if it is very low, then it is with the way you get the best fit for it. And it is you can see here these points meet, and mean square error is appropriate, and you can use this model to train. Error histogram is also there. I will not be able to cover all these things in detail, but if you just want to go for this neural network fitting, then only this can be understood. Otherwise, whatever I have covered the previously, the linear regression thing, then you can do that only. Okay, just a second. sorry for the interruption. Okay, so fit is also there, which if you have only few parameters, then the fit will be there. Otherwise, these performance traits enough for analysis. Okay. Any question regarding this? Because I have covered it very quickly. It is a bonus part, you can say. It's not like it is different from regression analysis what I have covered. But if you want to go for some kind of advanced regression analysis, then you can just learn this neural network based regression analysis. Otherwise, you can skip it if you are not able to find it like this. Okay. Any doubt, or you want to understand this uh, in more detail about this neural net fitting? Then I will try to cover this. Otherwise, regression analysis is the simple one which you can use to with your own data set. Okay. कोई क्वेश्चन, किसी का कोई डाउट इससे रिलेटेड, रिग्रेशन से रिलेटेड? एक there is one more kind of regression analysis there which we call as multivariate regression analysis. Multivariate regression analysis means you have more output values. So in general what we have input variables and we have one output variable. But if you have more output variables, yeah, more than one output variables, then this is called as multivariate analysis. It might happen. It can be useful in few cases, but in general, whatever you data download from the website, or you have some data set you have generated by your own. Most of the cases, it will happen like you will have input values and only one single output values. But in if it is if you have more output values, then it is multivariate analysis. This can also be done using this regression learner, but it is not like always there. It might happen in few cases only. Okay. uh any question, any comment
Yes, sir.
related to this?
Sir,
Yes.
what optimization techniques we use analytically? This I just saw this apps में optimization भी है. So is it the
यहाँ पे
same?
न्यूरल नेट वाले में
No, sir. Normal app मैंने करा click
यहाँ पे
तो
देखा होगा आपने, न्यूरल नेट में देखा होगा ये.
no, just close to curve fitting. The second option in the app section is optimization. And
Okay, okay.
by mistake, I somewhere I clicked it. So is it the same optimization techniques which we
Yes.
like transportation and assignment problem which we used
Yes,
to?
yes, 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 yes. This
Oh,
for the same. Yes, you can explore
okay,
this. If you are
okay,
in this field, then definitely it is quite useful for you. Okay, genetic algorithms and every optimization tool is there.
okay,
But I don't think in this FTP this is going to be covered. But definitely very good tool for optimization.
oh,
It
okay, okay,
uses your FMIN solver. Yeah.
okay. Thank you, sir.
For mathematicians, other tools are also there. PD, your PD for partial differential equation modeler is there.
App section.
This regression
So in the
learner,
app
we
section,
will cover it.
sir, pardon, sir, partial differential, what did you
PD
say?
modeler, yes.
PD.
This is
Where,
partial differential modeler, yeah, PDE model.
okay, math
Are you able
section,
to see my
maths, yes,
screen?
sir, PD modeler. Yes, sir. Yeah.
Yes.
So it will
So
solve partial differential equations also.
yeah, so this
Okay.
you can use this also. Okay. Mm-hmm. Yes, 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 yes. So for mathematician people, there are several options, and even you can install few add-ons also if it is not there. If it is not there, then you can go for get add-ons and try to download uh, uh, other mathematical. This option is also there if you don't find anything related. If it is not there, any app for you, then this is also possible. But further, and this neural fitting also, you can try this also. So these two things for today's try to explore these two. First, the regression learner, again data set with only one input, data set with multiple inputs and one output variable. You can select features and then you can try this with. Yes, yes, sir. Yes. So your voice is breaking. Yes, sir. Go ahead, sir.
Can you hear me?
But now I'm not able to listen to your voice. You there, sir? No. Okay, so any other doubt? Any other? All right, so I guess I will stop it
Sir,
here.
please,
I will.
sir, please if you can repeat something. Actually, I had joined for slightly late.
Try.
चलो ठीक है जैसा ये है बोलो
If any participant has any query, he may ask sir for further clarification regarding the topic being discussed today.
और पेयर्स में 463 जो है अब ये आइडिया तो वो उसी पर लगा के देंगे ना हमें हमारा आइडिया तो ये है उस वाले और उसमें से 27 ये जो है
Sir, I think we should stop the session here. Sir, Nikhil sir, are you listening me?
जो कैंसिल वाला है उसका सब्जेक्ट उससे हमें उतना माइनस करने में सुविधा हो जाएगी इन सब्जेक्ट्स में
Hello.
Yes, sir.
Yes. So I will stop it.
Yes, sir. Again, we will meet after lunch break for hands-on training on this issue. Sir? Sir, are you getting me?
Yes. Yes.
Okay, sir. Thank you, sir. Thank you very much for your wonderful deliberations in this session. So, again, we will meet after lunch break with sir for hands-on training on the issues which he has handled in this session. Let us take a break for some minutes. When the sir will, our next resource person will join, we will again meet together and we will listen to him. Thank you all. Thank you, sir.
Sir, hello.
Yes, sir.
Oh, can you hear me, sir? Can you hear me?
Sir, namaskar, sir.
Namaskar, sir.
Yes, sir, you are audible. Yes, sir.
Yeah, then fine. No, I want to check before start my lecturing. I want to check whether it is audio is okay.
Yes, sir, your voice is audible. If you want, we can continue the session right now.
Oh, no, if the participants want some break, it's okay. Otherwise, I'm ready. I can.
Pardon, sir?
Yeah, I am ready. But you ask the participants. Yes, all are there. The participants are there.
Sir, all the participants are here now. We can
Yeah, I
continue
can
the
make.
session.
Yeah, sure, I can.
Okay, okay, sir. Thank. Uh,
Sir, sorry for interruption.
today,
There is some audio problem. Please clear it, sir.
from which side?
Uh, Sir, from your side, there comes sometimes disturbances.
Also from my side. Now is it audible?
Yes.
Yeah. Am I
Okay.
audible? Am I audible to all?
Yes, sir, you are also audible.
Okay, fine.
Okay. So, in the second session, we have with us Professor Prasanna Kumar. Currently, he is working as professor in Devanagari University, Karnataka. His topic for discussion in this session is MATLAB for numerical solution of different equations in computational mathematics. Sir has a vast biodata. Let me talk a few about sir. Professor B.C. Prasanna Kumar obtained master degree in mathematics in 2000 and doctoral degree in applied mathematics in 2007 from Kuvempu University. Currently, he is serving as professor and chairman in the Department of Mathematics, Devanagari University, Karnataka. His research focuses are on both fluid and solid mechanics. He has developed mathematical model and simulation pertaining to thermodynamic performance of in national and international journals. He has 7,200 citations with 8 index, 52 and I-10 index 15. This record shows his popularity in the field of specialization. Nearly 25 reputed international researchers and 15 Indian researchers collaborated with him. Moreover, he is the editorial board member for several reputed journals and also reviewer for journals of high repute publisher like Elsevier, Springer, ASME, Emerald and many others. Recently, he wrote a textbook on advanced differential equations and it became more popular book for postgraduate students. He also chaired delivered invited talks at various national and international conferences. He is the awardee of seed money for young scientists for research, B Vision Group on Science and Technology, Government of Karnataka in 2014. Included in the recently published list of the top 2% most widely cited scientists in different disciplines for the second time, the world's top 2% scientists by Stanford University. Received the VGST Award for Research Publications 2020-21 in the field of computational and mathematical sciences by the government of Karnataka. Vision Group on Science and Technology, VGST, 5 papers have been recognized as a top cited article in 2020-21. In heat transfer, JAMM, that is Journal of Applied Mathematics and Mechanics, and numerical methods for partial differential equations, Willy publications. So sir has with us, he is a great personality. So let us participate in his discussion on MATLAB for numerical solution of different equations in computational mathematics. Over to you, sir. Sir,
Sir, am I audible now?
yes, sir, you are audible.
Okay. I hope it is shared. My desktop is shared, right, sir?
Yes, sir.
It is shared, right, sir? Is it moving? Is it moving?
No, sir. Only screen is there.
On the screen is there. It is not moving. Now I have moved that slide.
Yes, sir, it is not opening.
Okay, 1 minute.
చాలా ಕೇಳಿಸ್ತೈತಿ ಸ್ಲೈಡ್ ಮೂವ್ ಆಗಬೇಕಲ್ಲ.
Is it moving now, sir?
No, sir. It is not visible.
No, my screen is not visible.
No, sir. One old screen is there in the front, in the desktop. Your screen is not visible.
Okay, 1 minute, sir. 1 minute. ಹೆಂಗಪ್ಪ ಇದು? Hello, is it now? Is it visible? Hello, is it visible
Yes,
now?
sir, visible, sir, visible, sir.
Sir, I think it is
moving
visible
now?
to
Is it
others, but
moving?
it is not visible to me.
Yes, moving, sir, moving, sir.
Moving? Okay, fine, fine. Okay, fine. Shall I start now?
Yes, sir. You can proceed.
Yes, sir,
Yes,
yes, sir.
yes, yes. Thank you so much. Because initially it is a little tough to verify all the things whether it is going on. Thank you so much for the opportunity. So I would like to thank Professor Gaurav. He's my best friend. Since 2 days I am participating since this workshop. It is really useful because in fluid mechanics and also solid mechanics, I am using MATLAB, particularly this boundary value problem solver for both fluid and solid mechanics problems. In this present talk, I will concentrate on you. But before that, I will give one simple example. Particularly which arises in fluid flow problems. So actually, so how softwares used to solve boundary value problems? So we can use MATLAB, Maple, Mathematica, any software you can use. But MATLAB, I feel comfortable and easy, and we are getting more accurate solution when compared to other two. No, it is my experience. And even I will discuss common errors made in investigation also. And also I'll discuss a little bit about the analytical method, advantages of analytical method, and validation of analytical method. See now, validation is very important. That numerical method, whatever the software we use, we have to validate it. And I will explain few advantages of numerical method, application of numerical method, and also validation of numerical method. Later, we will discuss in detail if any doubts for the participants. So next, MATLAB. Anyhow, I'm not going in depth because all the participants are already well known about the applications and also its usage. Now I concentrate BP4C and BP5C. BP4C and also BP5C. Now, boundary value problem solver 4C we are well versed. Now there is very slight changes in BP5C, and now also we are using, and I will explain the difference between these two. Now in BP4C, I will explain some basic concepts of BP4C. So BP4C is a solve boundary value problems. It is a fourth order method. BP4C is it uses finite difference method code that implement 3 steps Lobato formula. It provides continuous solution that are fourth order accurate uniformly in the integral of integration. Actually, here it uses Lobato formula BP4C, but simply most of the others they write it is a we solved solution by boundary value problem solver BP4C. Instead of that, they can explain a Lobato formula in their research paper also. Now, few description. So we write solution by BP4C method. So ODE function, boundary conditions, and solution. It integrates a system of differential equation of the form y dash is equal to f of x5. So BP4C always integrates only a system of equation in first order. It should be a first order set of first order differential equation. So specified by ODE function, subject to the boundary condition described by BC function, and the initial solution guesses solution. See, the difficulty of using boundary value problem solver is, so initial conditions. So number of initial conditions and number of differential equations should match one thing. But in most of the boundary layer problems, I am solving on the boundary layer problems. With respect to that, few missed boundary conditions will be there. So those missed boundary condition should be guessed. You have to guess those missed boundary condition, and those missed boundary conditions we will obtain by means of shooting method. Later, I will explain that shooting method also. Now, ODE function to solve, specified as a function handle that defines the function to be integrated. ODE function and boundary value functions must accept the same number of input arguments. It should be same. Okay. Later, I will explain one problem. There you can see one simple problem explain. Later, one third order differential equation which arises in the fluid flow problems also I will explain. To code ODE function, we generally use the functional signature dy by dx is equal to ODE function of xy. Now BC function. To code BC function, use the functional signature res is equal to BC function ya and yb. For example, if ya is equal to 1 and yb is equal to 0, then the residual value of ya of 1 minus 1 should be 0 at the point x is equal to a. Those who are already using this boundary function, see, many are using directly the boundary value problem BP4C or BP5C simply a solve like that. No, you have to write a code. When you are writing a code, most of them are well versed for this. Y of a 1 minus 1 should be 0 at the point x is equal to a. Similarly, since y of b is equal to 0, I have taken y of b is equal to 0. The residual value of y of b at 1 should be 0 at the point x is equal to b. I have taken two interval. I have taken an interval of x is equal to a and x is equal to b, and at x is equal to a, residual value y of a 1 minus 1 should be 0 and y of b is equal to 0 at another end also. Now solution. Solution integer is equal to bv in x and y integer. Uses the initial mesh. You know the mesh, how we use mesh in the numerical method, particularly which uses meshing thing. And initial solution guesses y initial to form an initial guesses of the solution for a boundary value problem. We can use the initial guesses solution as one of the input to boundary value problem PC, BVP4C to solve the boundary value problem. And again, X mesh will come. This is particularly if you are using finite difference method and the which uses meshes. And initial guesses of the solution I have told already. So when we are using, when we are solving problems arising in fluid flow, when we are solving a boundary value problems, which problems arises in fluid flow and heat transfer problems, many initial conditions are missed. So those missed initial conditions, initial condition should be guessed properly. Now I'll explain how to take the initial guesses of the solution, but it is not always required for all type of problems. Only a few problems, particularly of third order differential equation in fluid problems, one or two initial conditions will be missed, and that we will guess by using a shooting method. Later I will explain that also. Form a good initial guesses of the solution to a boundary value problem is perhaps the most difficult part of solving the problem. So initial guesses. So why I am telling, so some problems may not have a unique solution. You know that. So in fluid flow problems, this will be having dual solutions. So your initial guesses should be close to your solution which you expect, because both the solutions are not reliable, both the solutions are not convergent, sometimes not convergent. Okay, of course, we can get both the solutions are convergent, but both the solutions are not stable. That is very important. So your initial guesses should be near to the solution which is stable. Even both the solutions that exist, both the solutions are convergent, of course, but we should not have both the solutions of particularly if we have a two solution, both the solution definitely will not be stable. One solution will be stable, so we should guess the initial solution very near to the stable one. Next up. So BVP solutions are not necessarily unique. You know that boundary value problem solution not necessarily unique. So the guesses can be deciding factor in which of many solution solver returns. Creating a good initial guesses for the solution is more an art than a science, because we don't know when we get a boundary value problem, we don't know which solution is a stable one, which is a more convergent one. So this is not rather than a science, it is an art. We are guessing a initial condition isn't just like an art, because scientifically we cannot do, and guesses means itself it is an art. However, some general guidelines we have to follow. Have the initial guesses satisfies the boundary conditions, since the solution is required to satisfy them as well. This is important. Have the initial guesses satisfy the boundary condition. Initial guesses we should guess like so that that boundary condition should satisfied well. Consider the placement of the mesh point. Again, the mesh point also matters when we consider the numerical method which requires a mesh. One simple example I will give. So, solution of a boundary value problem using BVP4C. You consider second order differential equation y double dash plus e power y is equal to 0 with the two conditions y of 0 is equal to 0 and y1 of 0 is equal to 0. Here x is equal to 0 and x is equal to 1, both y is equal to 0. Now, as I have already explained, second order differential equation is there. I have to reduce this into two first order differential equation. For that, now I will convert equation 1 into two first order ODEs. Now I will substitute. Let us take y of 1 is equal to y, and here anything can be taken, not y of 1 or y, some y suffix, y prefix, like that we will write. Here for my convenient I will write y of 1 is equal to 1 and y of 2 is equal to y dash. I have taken like this is a substitution. Now what about y dash of 1? It is y dash. What about y dash of 2? It is y double dash. Okay, this is the thing I have substituted, I have considered, and then according to the given problem, I want y double dash. Therefore, I did differentiation of this substitution. Y dash of 1 y is equal to y dash. Y dash of 2 is equal to y double dash. I have substituted here. See now. See, y dash of 1 is nothing but y of 2, because y dash of 1 is equal to y dash, y of 2 is also is equal to y dash. Therefore, this easily can be verified. Now the differential equation becomes y double dash, second derivative nothing but y dash of 2, and plus e power minus y, I have taken to right side, is equal to minus of e power y. So y means I have taken y of 1. Therefore, now our differential equation in a conversion mode, it is like y dash of 2 is equal to minus e power y of 1. After taking proper substitution to reduce the differential equation into a first order ODE, I have taken the substitution and all substitutions are substituted in the original differential equation and I have got like this. Now this is the thing I required. Now the new boundary conditions, see, y of 0 is equal to 0, y of 1 is equal to 0. Y of 0 is equal to 0, x is equal to 0. Y of 1 is equal to 0, x is equal to 1. This is a new condition. So now I will explain in a simple way how to write a MATLAB program in BVP4C. So functions RHS function and dy by dx, it is dy by dx, or anything is okay. Y of 2 minus exponential of y of 1. So see, this is y of 2 is equal to minus exponential of y of 1. Okay. Now file 2. Here I have taken a initial conditions. I explained the condition ya of 1, yb of 1. End. File 3. So this explains how our graph looks. Then this is the main point. And you can observe it is a very simple thing and solution and all these things. See, and x label, y label, this is a simple thing. But many of us already, we know it is a simple problem, can be solved like this. But when it is a coupled non-linear, then equations will be more. But obviously the conditions, initial conditions, and then converted condition also will be more. Then the writing a program may be little complicated, but it gives, in my experience, a more accurate solution. Even I got 10 to the power minus 8 accurate solution for a coupled highly nonlinear problem. So using different initial guesses. So this is the same problem with the different initial guesses also I can write. But this I have not write in lucid manner. But this is also possible. This is also possible. But instead of doing in a simple problem, it is better to do in a different files and you compare the solution. That is better. So in a single program, two different guesses, sometimes it confuses. Now, the next advancement is BUP5C. So two methods, BUP4C is there and BUP5C is there. And you can ask, what is the difference? No difference in programming, except little complicated conditions and little more ODE functions. You can see here, only the error part is good in BUP5C. Otherwise, BUP4C are more convenient. Call to ODE function is less in BUP4C, and again it is more. And boundary condition is less. So still, even BP5C is there. I use BP4C because it is very easy to handle and even less time is required. And only advantage of BP5C is this mesh points. The solution was obtained with a greater number of mesh points compared to 4C. Now, next, implementing a shooting method in MATLAB. See, shooting method we use mainly to get the missed initial conditions. This is mainly we use, but we also use it for finding a solution. Okay, and here let us consider a problem y is equal to f of x, y of x naught is equal to a and y of x1. It is transferred into two initial problems, y dash and z dash, with some initial values. Since this method is a 2-point boundary value problem, this is a 2-point boundary value problem. Of course, it has a two initial values, but I have not given in the detail. But this is one of the prominent method, shooting method. Most of the researchers in the fluid flow problems, they use this shooting method to get the missed boundary conditions. But of course, this same shooting method can also be used to solve the system of equations, but this is not so convenient because we have so many methods, and particularly we have Runge-Kutta methods. Runge-Kutta for fifth order Fellberg method I am using, and it is giving a very good result. And shooting method algorithm, convert BVP into equivalent IVP, boundary value problem to initial value problem, guess the value for undefined initial condition, change the guesses until the final solution satisfy the end boundary condition. This is actually the algorithm for a shooting method. But of course, the same algorithm for everything. But the only thing here is guessing the conditions. Shooting advantages and disadvantages. Solves both linear and nonlinear boundary value problems. Simple implementation. Effective when the interval is short. Means AB should be, if it is 1 to 10, it is not easy. If it is 1 to 2, 1 to 1.5, then definitely it is so convenient and gives very good result. But disadvantage is unstable for some problems. Typically, those of I nonlinear are unstable ODEs. This is not always it not gives a stable solution. Sometimes it is unstable. Requires a good initial guesses for the IVP, as the numerical method does not guarantee convergence. So one disadvantages of this method is you require very good initial guesses, particularly in fluid flow problems when there is a dual solution exists and you require a stable one. That is you require a lot of circus here to guess the initial condition, and this is one of the disadvantage of this method. But when we use BP4C directly without writing a problem, this does not exist. This problem does not exist, but I will tell you what are the difficulties there also. The length of the interval of the boundary value has a high impact on the result. This is one of the disadvantage. I have told here advantage also I have told. If the interval length is very short, it is very easy. And again, this is a disadvantage also. When this is a large interval requires a larger number of iterations, and sometimes it won't give a reliable solution when the interval is large. So now I want to compare Mathematica with MATLAB. This is only with respect boundary value problems, because Mathematica and all softwares are its own advantages. Its own advantages, but when solving a boundary when using a boundary value problem solver, or when solving a boundary value problems which arises in fluid flow problems, I feel MATLAB is good when compared to others. And even Maple, you heard about Maple, because I am not going Mathematica, it is equally good. But MATLAB, you may heard. So MATLAB, it is good for getting an analytical solution. Started of a symbolic solver, but it is now it is a numeric symbolic programming. Even it has a visualization tool, but matrix manipulation tools along with spare arrays is also there in the Maple. And one advantage of Maple is symbolic tensor functions also it gives. But when there is a numerical solution, then I feel MATLAB is damn good. Now I will give you the best example of a third order differential equation which is coupled. So this is, I have taken the example of Chakrabarty and Gupta. This is a published paper and that problem I am explaining. See the problem, first column. F third derivative minus f dash square plus f into second derivative minus m. This is an magnetic number. F dash is equal to 0. It is a momentum equation, and temperature equation theta double dash plus Prandtl number f theta dash is equal to 0. One thing, it is a nonlinear. It is coupled. You see here f is exist. This is a simple example. Even I have taken simple example. It is a system of two equation which is non-linear, but not highly non-linear. Of course, it is a non-linear and coupled. F is coupled here. And boundary conditions here, no need to guess as of now, but when you convert, you have to guess. F third derivative, 3 boundary conditions are there for F, 1, 2, and 3. F of 0 is equal to capital R, and F dash of 0 is equal to 1. And f dash at infinity, because we have considered infinitely long plate, that's why the condition of f dash at infinity tends to 0. As eta tends to infinity, f dash tends to 0. 3 conditions for f dash, because third derivative, okay, first condition is over. Next, for theta, it is a second derivative, therefore I have 2 conditions. At initially it is 1, and end at infinite distance, temperature tends to 0. As distance moves, eta moves to infinity, tends to infinity, then temperature tends to 0. This is what the problem description is. Actually, this problem, it is an fluid flow and heat transfer problem. Consider a viscous fluid flow over a stretching sheet of infinite distance. That's why these boundary conditions arises. So particular the infinity means at an infinite distance of the sheet. Now, either before if I say there is no difference, later only the matter is some conditions. I'll explain later. So you see how I have converted. Let f is equal to y of 1. I have taken f is equal to y of 1, and its derivative f dash is equal to y of 2, and its the third derivative f dash second derivative f double dash is y of 3. This is sufficient because y dash of 3 will become f third derivative. So with respect to that, I have considered f is equal to y of 1, f dash is equal to y of 2, f second derivative is equal to y of 3. Similarly, theta is equal to y of 4 and theta dash is equal to y of 5. This is sufficient. Okay, you see now what happens. Y dash of 1. What is y dash of 1? F dash. Nothing but y of 2. Okay, what is y dash of 2? Y dash of 2 is equal to f second derivative. F second derivative is y of 3. Next, y dash of 3. What is y dash of 3? F third derivative. F third derivative, come to this problem. Come to this problem. What is f third derivative? F third derivative is equal to f dash square minus f double dash plus m into f dash. Correct? Now I will convert. So plus f dash square. F dash means what? Y of 2 square minus f into f double dash. F means y of 1. Second derivative means y of 3. See, second derivative means y of 3. Plus m into f dash. M, it is a constant, into f dash. What is f dash? It is again y of 2. See, I have now I have ODE y dash 1, y dash 2, y dash 3, and finally y dash of 4. What is here? Y dash of 4 means it is theta dash. Y dash of 4 means it is theta dash. Theta dash means it is y of 5. Next, y dash of 5 means theta double dash. Theta double dash means here minus of Prandtl number into f into theta dash. Minus of Prandtl number into f. F means what again? Y of 1 into theta dash. Theta dash means what? This is y of 5. Now, I hope you got a clear idea. Okay, see, this is third order. First equation is third order equation. Second equation is second order equation. So, total order is 3 plus 2, 5. Now, you count the number of equation. 1, 2, 3, 4, 5. 5 initial, 5 first order differential equation I have in my hand now. Okay, so this is what it happens. Well, I hope you don't have a doubt. Even if you have a doubt, I will answer at the end. So now boundary condition f of 0 is equal to r. So as I explained earlier, I will take a of 1, a of 2, a of 3, like that. The conditions I will take, and y of a of 1 is equal to a of r. I have taken left side. Y of a of 2. Y of a of 2, I have taken minus 1, and y of a of 4 minus 1, and this initial infinite condition just I have taken yb of 2, yb of 4. So this is what I wrote it here. Okay. So now the same problems. Now the boundary conditions. ODE becomes this is in Maple. No, I will not go for Maple. Maple means you see simple. It is quite simple. You no need. What do you write? Boundary conditions, right? And D solve. It will give solution. Maple, we have to convert like this. Okay. So third order differential equation, momentum equation actually, a second order equation, it is an temperature equation, totally 5 ODE equation, and boundary conditions are also converted. See, this is what actually the thing to make a programming, and plenty of research papers are available on this topic, and many are explained in detail. Even if you mail me, I will explain how to convert a higher order ODE to lower order first order ODE and proper initial guesses. But many researchers are doing in choosing a proper value for infinity. You see here f dash of infinity, infinite distance is there. So now I will concentrate on that. The difficult, you see, in exact method, there is no problem. There is no problem. So it gives exact solution, there is no problem. But whenever we use analytical numerical methods, very first thing we should see is whether it is convergent. If it is convergent, what is the convergent point? If it is not convergent, if you have not taken sufficient calculation domain, then whole problem will become wrong. So now, even when you Google it, comments on boundary layer theory problems means you can get plenty of papers which they wrote a comment. You have taken less computational domain like that, they wrote a comment. Okay, I will discuss now. See now, if common errors made in the investigation of boundary layer flows, this is with respect to numerical value. If I have not chosen infinity value properly, I will go back to the previous slide. You see, f dash of infinity tends to 0. This infinity value, if I have not chosen properly, then whole thing will become wrong. For example, this is one of the published paper. So he has taken eta infinity is equal to some 10. But actually the same problem, not that Gupta problem, it is one of the problem I have considered. This is one of the problem I have considered. In that problem, author did a mistake. He considered eta infinity is equal to 10. Then he got a wrong profile. So it should be eta infinity. For a particular problem, eta infinity should be chosen is equal to 20. And this is one of the major problem when using MATLAB. See, MATLAB, it won't consider a domain which what is your computational domain, it don't consider, because